Today we're going to be talking about chapter 20. This is the first chapter in significance tests. We're going to be really discussing the basics of how to perform a significance test. What is its purpose? How do I manage the entire process? This is going to be part 1 of chapter 20's notes. We'll finish up later on in another video. To begin with, I kind of want to set up an example. And we're going to use astrology as the topic. Astrology is predicting the personality, someone's personality from the positions of the stars and the planets at the time of your birth. What happened, example is you had 116 people volunteer to fill out a personality test. After that, they recorded the birth dates, and they gave 3 birth dates and horoscopes to 3 randomly selected volunteers. Okay, and what happened was they took these personality tests, they took the birthdays and the horoscopes, and they wanted to match up the birth date to the horoscopes and the profiles. And so the setting was that they were given a single birthday, and they wanted to match up out of 3 personality tests, which birthday did they have. And we want to know what's the probability that they could do just what they would do better than just guessing, random guessing. And it's pretty obvious that if you took 3 choices and one of them is correct, then 1 out of 3 chances is correct. And so if we were simply blindly guessing at which personality test matched with which birthday, then we get a 33.33% chance, right? Or a 1/3 chance of getting it right. So if this person were to go through this whole process out of the 116 people and they get about a 1/3 right, that doesn't surprise me. That is exactly what I thought would happen if they were just guessing. But we know that natural variation happens, and they're not going to get 33% every single time with these tests. So there is a little bit of variation that I expect happens. Could I get a little bit more? Could I get 34? Could I get 35? Could I get 40% and still be okay, right? There is a limit. We've talked about normality. We've talked about things that are being 1, 2, and 3 standard deviations away from the mean. And so with that said, we need to come up with a way to determine what is just too far away from what's expected to say, okay, something is going on. Either I've got really bad samples, or I may have to reassess what I assumed to begin with. Okay. A significance test has some general steps. Now, this is not what we would consider our acronym that we're going to be using. We'll take care of that in the next video. In general, we have assumptions and conditions that we're going to take care of. Hypotheses, we have to come up with a test statistic, and we have to find p-values and make a conclusion. Your book takes a great deal of effort to put these into an order, a very clear order. So definitely, I know that you've already read your chapter. You've probably already taken detailed notes on it, but just in case you haven't done anything, well, let's just pause for a minute. This is going to be hard. This is going to be difficult. If you don't put any effort into this, you're not going to simply catch up on the night before the test. This stuff is deep, and it takes a bit of time for you to sort through all of the details. So pay attention, ask questions, come to Google Meets. Okay, this week and on Friday, this past Friday, I'm going to have the Google Meet session open during 3rd, 4th, and 5th periods. If you want to attend, I highly recommend you pick one of those times, at least on the lecture days, and Monday is another one of those days that you come in and you pay attention to the notes. Pay attention to how we do things, right? If you want to take off on the times we're just doing book problems, I totally get that. But when I'm going to be giving lectures, I'm going to have those times open, so anyone at home, whether you're a contact or you're a digital learner, you can attend and you can ask questions, or at least you can get the lecture notes just the same as anybody else. Okay. Next, couple things. Assumptions are exactly as they were before. We're going to have 4 assumptions. We're going to have randomization. We're going to have independence. We're going to have 10% and success or failure. And these are going to happen in exactly the same way as they did in the last chapter. So that's a good thing, right? Nothing new to learn there. The hypotheses. This is an entirely new concept, and that is a plural word, not just one. We need what we call a null and an alternative hypothesis. The null hypothesis is the idea that you're looking for some kind of effect, right? The null is the absence of that effect. The best way I can describe this to you is the idea of a courtroom. If you walk into a courtroom anywhere in this country, the hypothesis for this is that you are innocent. The alternative to that null is that you are not innocent, right? You are guilty. And so we are going to assume the null is true until the evidence mounts up enough for me to change my mind and reject that idea and decide that the alternative is true. The test statistic, you already know what this is. This is called a z-score. The z-score is something that you will absolutely be required to bring into this, just as the p-value as well. Now, these are the mechanical pieces of that. This is the math. This is the number crunching things. Let's be really clear. Your calculator, for the most part, is going to give you these two numbers. This is not a very big challenge to come by these numbers, right? As long as we know how to put it all into the calculator to start with, these are the things that come out of it. That's relatively easy. The p-value is a little difficult to understand. I know that we've used the letter P for about 12 things. And I'm sorry, here's another one. And this is literally, we always write, it's p-value. It isn't got another name for it. We don't abbreviate it in any other way. P-value is always what we call it. It is the probability. Well, let me back up. The p-value is a conditional probability. It's if the null hypothesis is true, then the p-value is the probability that you could get a sample result like you did. It is a conditional statement. If I ask you to define the p-value, if you never give me an if or a then part, it's wrong. You have to put an if-then statement. And it's always, if the null is true, then this is the probability the sample could turn out this particular way. Okay, a lot more on that. We'll spend a fairly lengthy time discussing this, especially even into chapter 21. Okay, the conclusion. This is one of the things where I take the p-value and I compare it to what we call a significance level. Now, we're not going to really define a significance level just quite yet, but what I will say is that for evidence, when your p-value is going to be a decimal value, right? If it's above 10%, we're going to say you really don't have a whole lot of evidence, right? If it's between 5 and 10%, I'll say you've got some evidence against the null. If it's between 1 and 5%, you do have evidence against the null. And if it's less than 1%, less than 0.01, you've got strong evidence. Those are generic, general terms. That is not defined in any textbook anywhere. It's just a kind of a way for you to decide in your head, is this a lot of evidence? Now, is that enough to reject the null? Well, maybe, maybe not. It depends on what you chose in your significance level, right? And more on that later. The conclusion would be something to the effect that you either reject or you fail to reject the null hypothesis because your p-value was either more or less than your significance level. And you would, of course, put this in conclusion. You would go in context of the problem, all that jazz, right? All that good stuff. Okay. The scenario happens like this. If you want to follow along, I highly recommend you try this. Grab your TI-84s, grab it, and as I tell you the values, plug these into your calculator so you can see what happens, and you can kind of go with it from there. We have a sample size of 116. We're going to perform a significance test to see what my results say. Do I conclude that this person really does have an ability to do way better than just random guessing? Or not, right? I should be able to determine that fairly quickly. Okay, first of all, my hypotheses are usually how we start off with. So we're going to kind of start here. The null hypothesis denoted HO colon P equals. This piece right here, that is not arbitrary. That is not it's not something you can, well, I'm not going to put that down. No, you put it down, I'm going to mark it wrong. Okay, HO colon P equals has to be there. And then you're going to, P0 here is a placeholder. What that means, it is the probability or the percentage in the null hypothesis. 0, sometimes called naught, or the initial value, or the 0 value goes here. In this example, we had 40 out of 116 people, right? So that's X, that's N. In the null hypothesis, we thought if they're guessing, they're going to get 1/3 correct. My assumption is that they're just guessing. I'm looking to see if they have an ability. So the null hypothesis is the absence of that effect. So this would be they're just guessing. So what's the chance they could get it right? And that would be 1/3. So 1 divided by 3 goes here, and you can type that directly into your calculator. Here's how you get to it. In your calculator, you're going to go over to, I'll write this down. You are going to go, it's going to be stat, and it's going to get over to the right 2 times for tests. And then you're going to go down to 1 prop z test. Now, I want to say that's like 5. Don't quote me on that. But you're going to go there, okay? If you haven't been using your calculator very much, I don't know how you've been passing the tests, okay? It is essential. The course was designed with that calculator in mind. It is absolutely crucial. You will not be able to pass the tests from this point forward if you do not have one, okay? These numbers are essential. These are ways we do that. I'm going to teach it this way, so make sure that if you don't understand it, definitely get in touch with me so we can figure that out. Once you pull that up, you are going to have several values, right? The first value is your null hypothesis value, okay? We're going to say that's 1 divided by 3. And you can type that right in. It's going to go 0.333 repeating. One thing you wouldn't want to do is to round it to 0.3. That is way too much rounding. 30% is not the same thing as 33%, right? 33 and 33.33, I'm okay with rounding to 2 places here. But to be honest with you, I want it to be as accurate as possible. I'm going to do 1 divided by 3 here. The next is we're going to have to put in our sample size and our value that we got out of the test, right? So sample size is 116. Our X value is equal to 40. They got 40 guesses right out of 116 trials. Okay, your alternative value, you've got the next value down at the bottom. You have a less than, you have a greater than, and you have a not equal to option. Okay, in your book, it talks about one-sided alternatives, two-sided alternatives. All of these things are what we consider alternate hypotheses, right? So if you have one-sided shaded, this is a one-tail test, but it's a lower tail. If you had a two-tail test, then it would be kind of, the probability would be shaded on both sides. Of course, here you have an upper tail or one tail here. Now, this one would be less than. This is not equal to, and this is greater than. Notice that the less than symbol looks a lot like an L. Please don't mess that up, okay? And please don't change the alternative because you think it's backwards in the calculator. It is not. If you choose to do that, it will most definitely be wrong. If you write less than, right? Here in this case, we're going to be using greater than because we believe that the proportion should be greater than 1/3 if that person has some sort of ability to predict. And so that's going to be pretty obvious that we choose greater than 1/3 in this case. Now we're only going to have to choose the actual symbol here. It automatically knows that to use the value that we type in P0, and that's at the top. That's what we use 1/3 for. You can go down and hit calculate. You don't need to do any of that other stuff. And it's going to generate a number of things for you. Number one, it's going to generate a test statistic, a z-score. It's going to generate the p-value. It'll also give you p-hat. Now, p-hat is obviously just x divided by n. This would be 40 divided by 116, right? So we can see all these values, right? The p-value can be done by using a table of values in the back. That's your z-table. In your formula sheets, or you can use it by using normal CDF. But by far, like 99% of the time, you are going to be going here in one proportion z-tests. Okay, that is absolutely essential. You've got to get that down, or this is going to be a rough ride. When you look at your p-value is like 0.39, so in other words, you round it to 0.4 just to make it easy to discuss. Normally, a p-value is kept at 4 decimal places and never less, right? P-value of about 40% does not provide any evidence against the null hypothesis. We could not conclude that the astrologers have powers, okay? Because 0.4 is an extremely high p-value. That's right, I said it is a very large p-value. So the larger this number is, the less evidence you have, right? So let me break this down. If this person is just guessing, if this person is just trying to do this by no powers and guessing. Then there's a 40% chance that I'll see them get 40 guesses out of 116 tries. This is almost 1 out of every 2 tries. That doesn't surprise me. That is exactly what I thought should happen. And so therefore, I do not doubt what I started off with. I was assuming they were guessing. This simply confirms that. If this was like 2%, then there's a 2% chance that they could get that value if they had 116 tries. For example, I think if you go up to like 47 or 48 guesses correct, you can go back into your 1Prop-Z test and change the X. Instead of 40, try 47 or 48. You'll see it drop below 5%. At that point, I would think, wow, they got a lot more right than I thought they were going to get. I'm surprised. This is a fairly rare scenario. If they're just getting lucky, if they're just guessing, then I would expect that to happen only 2 or 3% of the time. Then I start to doubt my original assumption, which was that they were just guessing. We've done our assumptions and conditions here, right? Randomization, they told us in the paragraph it was randomized. They're going to be guessing and they're going to be doing it independently, right? Their guesses in one try doesn't affect the other. 10% here, there's, I don't know how many volunteers. There's definitely more than 1,000 volunteers. Number of successes and failures, we had 40 successes and we had 116 minus 40 failures, right? So plenty, all the assumptions and conditions pass. So I think my math is pretty good. I did that check. So I'm going to go back to my original assumption. If I had had a p-value that was less than 5%, then I would reject this null in favor of my alternative, which says that they are getting more right than I expect, rather than just guessing. Something is going on. This person doesn't seem to be just getting lucky with their guesses. Okay? Now, in a nutshell, in a very short time, that is how we apply a significance test. And we're going to take that into a lot more detail. Over the weekend, in your first couple of practice problems, I want you to look at number 1, number 3, and number 20. 1 and 3 is just getting your null hypothesis right. Remember, the null hypothesis is the absence of the desired effect. The alternative is what effect you're looking to see. Sometimes this is easy. Sometimes this is quite difficult. Okay? Your alternative comes from the context inside the problem, so keep an eye out for that. Number 20 is a full-blown significance test. I have not given you the acronym. It's called PHANTOM. We will get that on Monday. I'll post a video on Sunday afternoon, Sunday evening, kind of giving you the summary of my little drawing video I made. So you can watch that to get a sort of an idea, or you can kind of follow the book. Practice these. Go back, ask questions. If you have any that I don't answer, please email me and we can have a conversation about that. See you next time.